Welcome to the first session of the 13th. I'm hoping everything goes well as far as the presentation is concerned. It's probably my first Friday the 13th presentation that I've done. But welcome to the talk, that's talking AppSec, the full version of it, which is actually called the Clutter That's Choking AppSec and How to Fix It. But it's just that the title was too long. That's Choking AppSec. A little bit about myself before we move in. So I'm Rahul. I'm one of the co-founders at V45. We are an application security company. Some of the up at night are listed here. A huge fan of AppSec and DevSecOps automation. Work pertaining to software security, threat modeling, automation, and so on. So we're going to talk a little bit about some of these things here today. Usually when we do the sessions, and this is probably my 20th time that I'm presenting this, I first had a version of this presentation earlier this year, and ever since we've done probably 15 or 20 times. And every time I do this, one of the things I get to get a sense of is in terms of really the composition in the room, in terms of how many of us are in AppSec and how deeply. I don't see a way here for us to kind of get a show of hands, but I'm assuming that all of you here are or the other do with application security. With that in perspective, let's move. Start off with really the product engineering state of affairs today, right? So that's happening from a product engineering perspective. Most of it relates to the change from just the delivery of product deployments. You kind of move from waterfall to agile, and then there are people who stuck in between the two, which essentially is agile fall or agile fail, as they call it. It's probably an Urban Dictionary term, but most of them are seeing a lot more shift in terms of go-to-market with their products, and obviously that comes with what I like to call accelerated deployment. Additional catalysts for deployments of products. I'm talking things like Chef, Puppet, Ansible. The whole DevOps movement has kind of which engineering kind of moves today. And we're also seeing a lot more in terms of an adoption of microservices and in terms of being products being architected by themselves. So a huge shift, not just in terms of the way products are deployed, in terms of how the products are architected and the way products are built, the team structures and things like that. And to a large extent, itself, you see a lot more in terms of the speed of testing by itself. So that's a huge change in terms of product engineering from the last couple of years. From an application delivery perspective, right? So I kind of see two, I probably want to divide the whole application delivery types of customers, if you will, right? You first have, typically I'd like to call it the difference between the east and the western seaboards of North America, right? Let's take the example of the eastern seaboards. You're essentially talking about large banks and insurances who probably have a large number of applications, but many times in a year. So you're probably talking about 3,000, 4,000 applications in some sessions, in some organizations, but you kind of see them kind of happening once or twice a year. And then you cut to the other coast, which essentially is the typical Bay Area, Silicon Valley kind of companies, or two applications, but then that's incredible in terms of the iterations that they have, that they do. We've all heard of the story of Amazon in seconds, but this was way back when Amazon had just adopted AWS, and we're talking almost 10 years later, and you can only imagine this would actually deploy. So from an application delivery perspective, you're kind of keeping up with this huge deployment that either happen in terms of scale of applications or the scale of iterations. You're kind of seeing both of these amazing views of the world from that perspective. Companies in between, right? You typically have the small and medium segment between both of these worlds, purely from a delivery perspective, right? They have a massive number of applications in terms of their portfolio, but have few of them that have more in terms of iterations from that. And unless and until there's been somebody who has who's really been under stone over the last 10 years or so, has heard of DevOps and the DevSecOps word. And if there are fans of Gartner in this room, I apologize in advance, but it's just that the current view of DevSecOps, which is the infinite circle of Gartner, is slightly confusing to a lot of us, and it has been for me personally. Is go ahead and change the way we'd like to look at DevSecOps from that perspective, right? So what you see on the top are the typical software engineering phases or stages, if you will. You have the plan, build, test, release, deploy, operate, and monitor. And what we've tried to do is on the bottom, we've essentially tried to map out the typical phase, which is threat modeling, static code analysis, dynamic analysis, security and infrastructure as code, and attack. So DevSecOps, in my view of the world, is really trying to retrofit the security phases of its respective blocks, if you will, in product engineering. And that's really what the color code here is. For example, threat modeling is something that starts off with plan. It used to be just something that used to be done at the design phase, but as you keep moving forward with things like threat modeling move just from the plan phase, and you kind of moving into the whole code aspect of things as well. Now, static code platforms, which is largely code, its way through build and a little bit of test as well. So you just kind of extrapolate that that statement in terms of how various engineering are really trying to kind of expand themselves into their respective positions in product engineering. And this color code here has changed. See the orange probably move more towards the right as we keep shifting threat modeling left, and the other things would kind of retrofit. Kind of put this description or this representation of DevSecOps and DevOps just to throw an idea out there. Put this idea out there. I'll kind of be interested to see in chat if anybody have any opinions or feedback in terms of what you think architectural or really from a diagrammatic perspective of what DevSecOps could mean from that perspective. So where does application security kind of feature in this current scenario? Thankfully for everybody, today, security is no longer just an end of the chain activity. It's almost become like a piecemeal kind of engagement broken down into smaller chunks. The DevOps and the DevSecOps movement has kind of picked up, and businesses across the plane want to move faster. They want to go to market faster. And DevSecOps, therefore, amongst other things on the screen that you see here, has kind of led to increase in tooling, test management, build management, deploys, post-deploys, etc. And security too, thankfully, has moved from a traditional a gatekeeper function to a point today where it kind of embeds different pods, if you will. But all of this obviously means that we're using more tools than what we were using when we were a silo. This also means that integrations between tools from one unit to another also is quite significant from that perspective. Kind of numbers, and these numbers intentionally from reports of 2016 or 2017, because I wanted to just kind of, want to make us appreciate the kind of scale that we're kind of talking about. Just one second. Yeah, in terms of just the numbers here, right? So you're kind of seeing mature DevSecOps shops generating close to 8,000 vulnerabilities, but which is great in terms of finding issues. How these issues have been remediated, you're kind of looking at close to 30 days or 35 days at an average for somebody to patch an application security. But I'm going to keep this, just want to throw this number out there because it's just something that for security professionals and for product engineering professionals to just kind of ponder about. And from a remediation perspective, as much as we've done from finding issues in right. So and this is where I want to kind of create a segue to today's talk, is in terms of understanding what is it that stops product to fix bugs as much as we're able to find bugs early, right? So that's really where we're kind of going. The development and deployment architecture in the recent times has also kind of increased significantly, right? Today you have components to assist than what you have probably a decade ago, right? And more components in context with more tools, and more tools means more scanning, and obviously all of this is going to lead to an information overload, right? And that's really one of the biggest aspects of what application security is dealing with today, is in terms of all of these great tools times the number of components times the number of iterations, and that's going to lead to a. So let's see how that data kind of plays into application security engineering as we see it today. Obviously, with information overload, there are some challenges, and we look at some of them in more details. But just as a pointer, some serious constraints in terms of availability, in terms of time spent in triaging issues, sorting issues, and we'll see this later, where tools have some major inconsistencies in terms of the way they represent data, in terms of how they kind of lay that information. And finally, you have a lot of constraints in terms of just managing those kind of vulnerabilities. Bandwidth, it still remains to be the single largest constraint with AppSec teams in the current scenario. Agile, they're hiring more developers, they're hiring more agile project managers, more operational folks, more cloud engineers, but almost nobody from a security perspective. And when I mean from both sides, right? In terms of, do they know what they need of a security engineer, or do they know what they need of an application security, an infrastructure, network security engineer, right? So something that we've kind of noticed in a lot of forums like these, or when there used to be a time when they used to do meetups and things like that, you always have headhunters saying that we've got openings for security engineers, but then realize in terms of what they wanted those engineers to do in the first place, as far as the profile was concerned, right? Which is, I mean, and they get to work on some of these initiatives that we've talked about, but there's another side to the story that kind of goes mostly unnoticed. How a typical security engineer's time is spent in information. And I like to take the example of this fictitious character called Jason, and let's say it's Jason the tester, for example. He works as a lead security engineer in, let's say, a digital, let's say in a financial technology company, right? It's a fintech firm. Of conversation here. Months into this work, and let's kind of understand what Jason's day in the life of Jason from application security perspective. The role and responsibility would include them doing security assessments, which is great. A pen tester or a security engineer is supposed to do security assessments, complaints there, help developers in terms of remediation. Great, no problems there as well. And then if you're a financial technology company, you probably need to help your CISO or your head of compliance with compliance audits. Okay, still, and then you've got a gap security reports. You've got both tools, which is still okay, perform threat modeling, automate those tools in CI/CD, validate fixes with that you've helped them validate fixes once, but then they might not work. You come back again, you do iteration there, and you review those vulnerabilities, respond to customer questionnaire, security. Almost no time left for security research, which in my opinion is a very, very integral part of what an application security engineer is supposed to do, which is security research, because you're living in a very, very dynamic era as far as AppSec is concerned. And obviously you need to kind of be able to update yourself from that perspective. Now, on top of this, if there's somebody who's going to come and say that they need to really continuously, Jason is not happy. And this is kind of interesting that today is the 13th of Friday, and Jason is not a happy person because and there's really a difference in terms of what an applicant wants to do and what he or she is currently doing in terms of available bandwidth. Among these issues, presentation on just one thing, which is that of managing vulnerabilities, right? And this really brings us to the core of today's topic, the clutter in AppSec, which is a clutter caused by that of managing vulnerabilities. And say that an application security program is only as efficient as its vulnerability management process, right? And having all these amazing tools and platforms, teams and processes, if software vulnerabilities cannot be efficiently generated, if they can't be shared, remediated, and probably finally sometimes not even be able to prevent them from regressing back upstream. Probably the single most significant reasons that prevent product and security teams from being able to kind of gap between the ideal and the practical of DevSecOps, and for them to be able to kind of increase what we like to call this product through. So let's kind of dig into this. Okay, so I see that there is lag. Chris, just let me know if you guys, if everybody else is feeling this. Like I said, I can kind of swap out my audio if it's still continuing to be. So I'm just going to give it a couple of more minutes to see if that's better. Anyway, so let's dig a little. Actually do this. It's kind of essential that that we understand the vulnerability. Right. So before we kind of talk about how do you manage vulnerabilities and things like that, it's very essential that you kind of talk about how do you what. But before that, no, I know this is the B-Sides chapter conference, and there are a lot of accomplished security engineers here. But trust me, the number of times either in an interview or in a security report that I've seen people get really confused with these three terminologies of CWE, CVE, and CVSS. There's often an analogy that I compare this problem with. I think the CVE, the CWE, and the CVSS are the Baldwin brothers, famous one, if you know what I mean, right? No one really gets the others' movies right the first time around, and they always kind of get them confused in terms of who they are or what they do. And for people who are interested, the one on the far right is Daniel Baldwin. Check him out in case if you're interested, if anybody can kind of recollect what movies he's been. Anyways, so at the risk of some of the security experts really grinding your teeth here, a quick 101. And trust me, this is important because when we talk about managing vulnerability at scale at a later point in time, at the risk of some of you really kind of grinding your teeth, I'm just going to quickly go over this. CWE is essentially a kind of system for categorizing software vulnerabilities, right? So it has over 60-odd categories, including cases for buffer overflow, SQL injection, race conditions, and so on and so forth.
and it's essentially a bucket that you would kind of put a particular vulnerability within. So in case that in terms of a particular vulnerability, you would take that and you would kind of assign a CWE value to it. The CVSS is the common vulnerability scoring system, and this is essentially a free and open system, an open standard really, for kind of assessing what the severity of a vulnerability is. It kind of attempts to assign severity scores for every kind of vulnerability that you find. And this is where you would probably have people who work in security or not, who kind of know like a CVSS calculator and what the impact of that vulnerability is to that particular scope by getting a value of what that severity is. Now that's the CVSS. Now the CVE is the common vulnerabilities and it's kind of a dictionary type of a list of standardized names for vulnerabilities. So which means that every time there's a new vulnerability that comes in, you'll probably CVE database. And CVE essentially aims to kind of publicly listed exploits or publicly listed vulnerabilities. So that's really the CVE. So you've got CWE, which is a categorization. You've got CVE, assessing severity of vulnerabilities, and then you've got the CVE, which is essentially a standardization of names. Now, with this in mind, let's kind of move forward in terms of tools. Now, tools are great. They make our lives easy. They're able to kind of find flaws in ways and approaches that manual pen testers might not. And they also kind of generate the data required to find these kind of issues. But tools have inconsistencies and alike. And they have what kind of they have inconsistencies in the way that they produce this data. And they have different verbiages for those names, which means that they would probably call a blind SQL injection a time-based SQL injection, different ways, therefore confusing the audience in some ways. And most tools kind of rely only on, for example, right? So some tools might give you the vulnerability information with the CWE, and some of them might not. So that kind of creates another kind of manage results coming from two tools. Even today, very popular open source tools like Bandit and Drakeman, there's no CWE. So how do you kind of backtrack vulnerabilities from these tools and kind of tie them back to a common nomenclature? So that some of these tools don't give any taxonomy. So you have no idea if these tools talk about, let's say, not against the SANS top 25, or are you kind of benchmarking them against NOVAC? So what are you kind of baselining these vulnerabilities? So some of them don't really give you those taxonomies, right? And then you always have the problem of false positives, which we'll also talk about in a little. So tools by themselves have a lot of inconsistencies, and that kind of adds one step further to the existing clutter that we kind of talked. Let's say you're running a SAST, SCA, and a DAST, for example, and let's say you find SQL injection. There's a good possibility that each of these three tools are going to call SQL injection. For example, a ZAP or a burp might call it blind SQL injection. A SAST might call it a time-based SQL injection or something else. And believe me when I say this, because we've literally tried doing this for almost a year when we were kind of building our inclusion. Tried every combination in the book. We tried to map these vulnerabilities based on string matches. We tried doing this based on Levenshtein distances. Really still has some level of inconsistencies. And what is kind of made worse is when you kind of throw in a vulnerability scanner in the mix, which does not give you a CVE, right? Which by no means, like we've seen in the examples earlier, gives you any information on what the actual vulnerabilities are, right? Perspective, just to show you what some of these inconsistencies might be. On screen is a snapshot of a vulnerability of an intentional vulnerable application. So no, the top is from Akunetics, and one on the bottom is from check marks. We're essentially trying to compare a DAST and a SAS vulnerability. Both of them are applications about the same vulnerability, which is that of CWE 17.9. Whereas Acunetics calls it as vulnerable JavaScript. Vulnerability by check marks is called as reflected XSS. Completely two different names for the same vulnerability. AppScan and Burp, two DAST platforms. Same vulnerability, CWE 693. AppScan calls it insecure cross scripting. If you can read that on the screen, it's the one with the box in there. And then Burp calls it protection mechanism failure, which has nothing to do with cross scripting. Again, consistencies. Let's take two SaaS platforms. Both of them are static code platforms. FindSec Bugs, Veracode. CWE 89, which is the same vulnerability, SQL injection, but different names. Now, sometimes you don't even get a CWE. This is again CWE 89, which ZAP gives you for SQL, but nothing from its SaaS counterpart, which is also an open source OWASP project called the Node.js, not an OWASP project, I'm not really sure, but it is an open source project called the Node.js scan. It does not even give you a CVSS. When this is run in scale, such tools, especially as part of nightly builds or daily builds, there's just so much issues that are generated that what you see on here obviously is a very, very simple pipeline involving a couple of tools that you use to run against our own CTF application. But the idea really here is for us to look at the results, not just in terms of the type of issues, but also in terms of a format in which these results are kind of generated, for you to be able to kind of appreciate the issue at hand here, right? Some of the other Clutter contributors, false positives. We all have false positives. Everybody talks about false positives with tools. And one of the things that I want to lay out at least it's a personal opinion of mine, I'm sure a lot of y'all share this, is if people ask someone if there is a tool out there that can eliminate false positives, to my best ability, my best knowledge, there isn't a tool that can eliminate false positives, because we've still not got to a point there where from an application security perspective, you could probably eliminate false positives infrastructure tool or a security platform. But for an application security platform, completely eliminating false positives to absolute zero is not possible. But what manage false positives from that perspective, right? For those who are interested and those who've kind of used tools like Burp, you will know that Burp has something called a scanner confidence score. And that's a score that Burp uses to kind of give you a certain of where a particular vulnerability is actually one. And that's the extent to which Burp goes, and a lot of other tools don't even give you that, right? False positives, managing false positives, big contributor from a Clutter. The other one is in terms of prioritization or severity. A lot of us rely on the severity scores given by the tools themselves. And the fact of the matter is the tools don't understand your application's context. The same tool can be run against a banking application and a retail application. It's going to look at it the same way. The prioritization or the severity of the vulnerability is oftentimes a product of the score in which that vulnerability is found. So it's very, very essential that AppSec engineers and product team kind of realize that severity kind of is that barrier between application teams finding issues and development teams fixing those issues in the same speed and mode. Incorrect prioritization, incorrect severity scores kind of create a lot of turmoil in terms of the way security bugs are either found. Remediation. A lot of us depend on the remediations given by tools. Now, to a certain extent, until recently, I thought that checkmarks buying off Codebash, for example, was the right step in this direction, because you kind of had give out a better remediation strategy, which is very localized to that particular issue that's found. but oftentimes don't happen, or they don't happen quite well, or they don't, or there's no source for finding remediation. So it's very important that given remediation strategies that are alternate to the primary one as well, because oftentimes you'll see that the remediation that's given is either insufficient or correct. So in those cases, you probably have the developers trying to go fix issues that don't work quite often, and then you kind of come back and say, hey, this is not working. Right? How do we declutter? Now, we've talked about clutter contributors, but now we're going to let's kind of see what's really the solution for this one. Is really two things, right? I'd like to call something as find early, fix early. And this is more philosophical than just a technology problem, because it's very important that any new tool, any new process, any new person that we get into product engineering today kind of fits in one of these two buckets. Is that introduction of that new element, whether it's a people, process, or technology, is it going to help security engineers find bugs early? Is it going to help application developers fix that bug early? And it's very important that we kind of maintain the balance between find early and fix early, able to kind of have some method in the madness to be able to kind of fix these clutters from that. We kind of I'm just going to throw three potential solutions here. And the first one is that about, I want to touch upon is vulnerability correlation. Correlation is probably what a lot of organizations are using today. Now, going back to our previous discussion, let's say you have a string of tools in CI that runs on means that you're going to get results across all of these tools. Now, correlation platforms essentially help security engineers triage, having an application security engineers to actually say, okay, this result from ZAP, this is section, here's something else from SAST, and both of them same, and before I actually go ahead and put that in the report. The correlation platforms help you do that. They're essentially like a noise cancellation device. You remember the time from, let's say, Toronto to Vancouver, for example, and you look at you open up Expedia and see how many flights are there at the same time, and you're like, interesting, 7 flights that take off at the same time and land at the same time. But you kind of go dig a little deeper, you'll actually see that they're just code shared across 5 airlines, but the actual flights are just 2. So it's very similar from a vulnerability perspective. You probably vulnerabilities coming from tools, but essentially, if you kind of correlate them, you'll probably zero down on 25 or 30 different unique vulnerabilities, especially if you're running vulnerability tools in scale. So correlation platforms really do that. They help you deduplicate vulnerabilities. They help you vulnerabilities. They help you declutter false positives to a certain extent as well. So correlation platforms really kind of give you that level to a certain degree. The other thing is security as code. I'm going to spend a couple of minutes here because this is probably the most controversial slide in all of my presentations. Now, over the last decade, if you will, security engineers have always gone to developers and say, hey, we're doing this great thing, write more proactively secure code. You need to be able to remediate fixes faster. You need to be able to write secure code faster. There's been this constant bashing of developers need to understand security. And it's about time that we said security needs to get code. And I say security needs to get code too for the following reasons. Let's look at the practical reasons of security needing to understand code. We're talking about application security. We're talking about a need to scale application security. And in my definition, anything that's automation, the line word for automation is code. So code times N is automation. So how are we going to be able to automate AppSec? Don't understand code at its granular level. You're going to be able to automate code. You're going to automate tools ability to look under the hood of open source scanners like Zap or whatever it is, and be able to kind of automate them with CI/CD platforms. Yes, there are plugins available, but if you really understand code, so that's another benefit of security engineers being able to understand code. From a philosophical level, we've all the siloed approach of developers and security. They've always been nemesis from that perspective. It's kind of soft. It's not as bad as it was earlier, but you still kind of really kind of working as much as you want to. But because one of the causes could be the fact that development communities talk their language, if you will, is code. They always are talking about what's the latest and the greatest happening in terms of programming languages, technology stacks, and so on and so forth. So if security engineers are also to talk the same language, it's almost that you get into that tribe of developers, and therefore probably empathy, in a mutual empathy between security and developers, because once a developer understands that the security person understands, the way the conversation goes is going to be much different, and you're going to get a lot more buy-in from product engineering than earlier, right? Security engineers really start picking up code because that's the way the industry is going as well. I can speak for myself at close to 27 security engineers, and all of them are at some point in time. And for us, it's been easier for us to teach security to a developer than teach security. A lot of unlearning and learning that's involved. So that's just us. But just kind of putting that out there, I know a lot of them have had alternate opinions to this. Maybe we could discuss that as well offline. But that's a very, very important aspect of Clutter. With code, you can do some very interesting things, like be able to automate exploit scripts, which means that business logic flaws are no longer dependent on the individual, but it's actually dependent on a script that runs on behalf of you. So that's a great thing. Able to potential security, because you have functional regression suites that create regression scripts for every iteration, ensuring that the same functional vulnerability does not really come across in a new version. Very similar analogy possible with security as well. And focus remediation. And if you understand code, you'll be able to kind of really come up with alternate remediation strategies once the development team gives you a pushback to the primary remediation. This fix doesn't work. Okay, what can be the alternate fix? That's an easier conversation to have if there is that whole adoption of code. And the last one is that of really integrating security and engineering from both a perspective and from a philosophical perspective. Again, because we've all talked about integrating security and engineering. We work in data, but at the ground, security teams are still working in PDFs, right? Everybody is still working in PDFs, irrespective of what you could have. There's still a PDF on the table. That some team in the organization that says, I'll only agree if there's a PDF. But engineering teams are still working in tickets, right? So, which means that there's a need for product engineering teams and security engineering teams to really, what I like to call, transform defects, transforms vulnerabilities as defects, because you kind of have these two different views of the world. The security teams look at vulnerabilities, whereas the engineering teams look at defects, and both of them have to be the same. So the problem is you're kind of talking in two different languages. So integration today is either a spreadsheet or a PDF, and both of them don't really kind of work frame of things, because when we talk about integration and when we're actually called in to create an integration project, the biggest issue that we see is that on almost 6 places, vulnerability management per se is done using sheet is probably the most common business intelligence tool that you're going to see there, or a vulnerability correlation tool that you can see there. Or we encounter the dreaded PDF. Reports in PDF, compliant audit reports are in PDF, which is very, very difficult to track and manage in terms of workflows. So it's important technology, whether we're kind of onboarding new tools from a security engineering perspective, or when we're onboarding new platforms from a product engineering perspective, is see if these can be integrated. And most of the tools today, thankfully, have APIs that kind of help you integrate with these tools. But it's very, very critical that all components within product engineering from that perspective are able to indeed kind of collaborate within themselves from a seamless perspective as well. Some interesting integration points here. CI/CD, a lot of them are doing this. Tools integrate with CI/CDs, bug trackers integrate with tools, and therefore all of them talk to each other, which is great. Tools talk to bug trackers as well, which means most of them today, any tool worth its salt today has a two-way sync with platforms like Jira, which means that you can just kind of just push vulnerabilities directly as Jira tickets, and people just, the developers just pick on them and start working on it. In some other companies, we've seen bug trackers actually being integrated as part of the Slack channel, which means that every time there's a bug created, there's a Slack channel ticket that's created directly to that individual, so it's much more faster. And you kind of seen a lot of more dashboards, right? So you kind of see a vulnerability correlation platform integrate with a bug tracker, and both of these together would probably integrate with with a third dashboard, let's say for senior management or executive dashboard or something like that. So a lot of possibilities from an integration perspective. Okay, so in summary, I'd like to leave you with this thought. From a core vulnerability management standpoint, I think should be beyond just traffic light indicators, right, of high, medium, or low, because the sheer number of issues that right. So when there's in my opinion, there's actual value in studying what I'd like to call the metadata of vulnerabilities, right? These are important, but what if there was an opportunity for us to kind of look beyond those traffic light indicators, right? For example, trove of information that you might have from vulnerabilities, what kind of patterns can we kind of look for? What if we see that these correlation platforms from telling you that there are more issues in design vulnerabilities that kind of have a root cause to design? So that your modeling efforts as opposed to investing in dynamic analysis platforms. Let's say that you're finding more issues from a SaaS perspective. You need to probably address that with developers as opposed to building on third-party libraries, for example. So I think it's important. I always say this: the last decade of 2010 to 2020 is a decade that gave time slot in product engineering. That's how I like to say, right? Because we now enjoy a position in primetime product engineering where people listen to AppSec. There's a lot of importance given to AppSec, right? So, and it's left to us in terms of what we want to do in the next couple of years. Where are we going to take the discussion of? Are we going to address the cultural challenges of implementing AppSec in scale? Are we going to talk about more tools, or are we going to talk about management, for example, or is it going to be training? So with that in thank you all for being part of today's talk here. If there are any questions, take them. I'm just going to quickly look into the comments here if there are any questions. Thank you for those who found the session useful. Okay, I'm just going to kind of probably stop sharing and then wait for any questions that any of you all might have. Thank you, Ken. What's your advice on legacy garbage, like old school C++ that folks know they need to fix but don't know how to start? I don't know, because what was the last time we worked on a C++? No, we worked on C++, but it's always some kind of refined form of C++, right? So it's not, but yeah, I think from practically speaking, I think it all goes back to conceptual understanding of security, because I always say that product engineering and application security are not too far apart, right? If someone knows the art of building applications, the art of breaking applications is not too far. If you really kind of look at both of them at the same point in time, when you kind of give some space, then they kind of diverge into much different ways, right? So yeah, maybe that's one way to do that. Thank you so much, and have a great rest of the conference as well.